Okay, this is Notes Multiplication Law of Exponents. As you can see, it says that an exponent consists of two numbers, a base number here, and an exponent or a power. What we're going to be looking at are laws of using those exponents in a simplified form instead of having to write it out each time. We're going to start out with expanding it, and then you can see what the rules are. So if you look at this first example of b to the third times b to the fourth. If we write it out in an expanded form, we have 3b's here, 4b's here. Multiplication means that we can add all of these together and we get b to the seventh. So our rule tells us that for any number b and any positive numbers, integers m and n, that when we multiply by the same base, which means our same number, that's our large number here, keep the base and add our exponents. So we have b to the n plus n. So we're going to do some examples down here. X to the third times x to the fifth. If we write an expanded form, we have 3 x's. 1, 2, 3, 4, 5 x's, which gives us x to the 8th. On the second one here, anytime that you have a letter without an exponent, it's understood to be 1. So here we have 3y's, 4y's, and 1y. All of those are multiplied together. So if we add them all up, we end up with 8 again. It has to be the same base when we are multiplying. Same thing if we have these. We have a plus b twice, a plus b 3 times, and so if we add all those together, we end up with a plus b to the fifth. Now, as you can see, you would not want to have to write that every single time if you had it where you had to write 10 or 12 times or more. So we take the shortcut saying 2 plus 3 gives us 5. We can only do this with like bases. So here we have a to the third and a to the second. So if we write all of this out, we have 3 a's and 2 b's times 2 a's and 4 b's. Add up the ones that are alike. We have 5 a's, which is what our exponent tells us, and we have 6 b's. We're not multiplying the exponent. If you're multiplying the same base, we're going to add the exponent. 3 plus 2 gives us 5. 4 plus 2 gives us 6. On these, we can write it out in the exponent form and in numerical form, which means to multiply it all the way out. And you can do this using your calculator. So if we start out with 2 to the third and 2 to the 8th, we can add our exponents and we can get 2 to the 11th. And so when you look in your calculator and you put 2 to the 11th power, then we have 2 11 times. Which I believe comes out to be 2048. On number 6, if we add our exponents, we have 5 to the 6th power, or we can write that as our number using our power of our exponent. We have 5 6 times. Which is a pretty big number, 15,625. Just depending on what the question asks, whether you want to leave it in exponential form or leave it in the regular form. When you have a negative in parentheses, we've talked about negatives quite a few times. We've got to be very, very careful about this. If you have the negative, it means that negative has to stay inside to the 5th power. Just like we talked about before, if you are multiplying and you have an odd number of exponents, you get an odd number. So since this is going to be negative 3 multiplied together 5 times, we have 5 negatives, it has to be a negative number. Then we can have 3 times 3, let's see, 27, 81, 243. So we have negative 243. It's going to be different if the number is outside of parentheses. So I want you to add this note here. If this had been negative 3 to the 4th power, this way, we have negative 1 time, 3 4 times. So even though it's not an odd exponent, we're only using the negative 1 time. So you have a negative here, and we have 81. So be careful if that negative is inside or outside. Okay, on number 8, we have 2 3s here and 1 3 here, so it's 3 to the 3rd. We have 5 and 4, so that's 2 to the 9th. And so we come up with 3 to the 3rd is 27, and 2 to the 9th, we have let's see, I figure out what that one is. 4, 128. I'll come back to that one in a minute. I've got to find my calculator here. So let's look down here at the bottom. When we have the guided practice, we have sum of each part. Okay. So that one's going to be 10x to the 7th. So try number 10, and then I'll put the answer up there to it. And this is 512. Go back up here to the top. So we have 27 times 512, which again is a very large number, 13,824. And you can do that all in one step in your graphing calculator. Okay, so on number 10, you have the negative out here 1 time. And then we have 6 times 5, which are not the same base. They're not included with the y's. So we simply say 6 times 5 is 30, add the y's, and we end up with 12. So when we're multiplying with exponents, if we have the same base, then we can multiply those or add the numbers on top as the exponent, and we can combine it in a more simplified answer. The next one will be on division of exponents.